Yep, everything's good to go. Fortunately, you all are a little more.
All right, good morning. It's about 10:50, so let's get going. I'm Brad Robson. I'm a principal with Palmer Engineering, and I'm a structural engineer. If you've ever heard structural engineers talk, and I hope you haven't, we talk about things like fracture critical members, critical buckling load, modulus of rupture, all these serious, scary sounding things. It's like we're in a crisis mode every day. And so it's fun when I get to spend some time with my more laid back roadway designers who talk about roundabouts and traffic circles. And, just comparing the acronyms that we use. Structural Design Code, LRFD. What's that? LRFDA. Okay, what do you guys use? The Green Book. Just much more laid back. I found out this morning that an R-cut is not a piece of meat. And a loon is not a black and white bird with red eyes. So with that, your presenters today are Brad Vaughn down in District 4. He owns this project, right? And Mike Vaughn, who we call Mr. HSIP. And then David Lindeman. David just started at Palmer Engineering 35 years ago, but he can do some amazing things. He can stop time. He can make rivers flow backwards. So you'll enjoy his presentation here today. So with that, let's get started.
Thank you, Brad. If anybody wants to move up front, it'd be easier to see some of the graphics on the screen. So they make all these rooms long and deep, so it makes it hard to see the PowerPoints. But I'm excited to be here today to talk to you about US 31W in Hardin County. You can see from that aerial picture, these are the only two curves on the project. Everything else is just straight as it can be for a long ways down through there. But this is the story of a project that had 4 different funding sources, a lot of twists and turns and changes as the project evolved over a few years. This is a video of what the existing conditions are. So prior to construction, you see that's 31W bypass in the lower left-hand corner. As you go up here, you see that there's really not much access control through here. It's just an open median with turn lanes going both directions. You can see the Amazon Prime truck here is about to turn left into the just kind of free flow. It's free for all to turn. Actually, it's going to U-turn and then turn right into the businesses there. So there's people doing all sorts of crazy things up and down through there. As you get up past the next intersection, there's a yellow car up here. This is one of, I guess what you call Scott Thompson's low self-testers. He won't turn across that traffic until he gets a huge gap, but he does keep creeping across into the oncoming left turn lane. So he's sitting in the oncoming left turn lane.
We need to share the screen.
Oh,
No, sorry. I thought it was already shared.
go ahead.
Sorry. No. You may have to just click more.
It's not clicking either way. Okay, so back to the video again. Welcome to everybody online that wasn't seeing the screen share. And so this is the uncontrolled access on 31W. So a bit of the history of the project. We started with an access management project about 10 years ago, working with John Moore in District 4. It was from 31W bypass all the way to Radcliffe, about 18, 19 signals in that stretch. We were looking to close the median up. There's some of it had grass median, but we were looking to close the median up so that there was better access control. Strategically eliminated, I think we eliminated 2 or maybe 3 signals, the whole corridor. But that project just languished because of political opposition. They didn't like the idea of U-turns on 31W. They thought there was too much traffic out there, thought it wouldn't be safe. So the project just sat for a while. So jump forward to 2015, there was an HSIP scoping meeting, and Palmer was very fortunate to be on the first HSIP contract. We went to that scoping meeting with Jared Stanley and Mike Vaughn, and Jared very passionately told a story about being from Michigan and having experiences driving on what he called Michigan U-turn roads. And this is what you see in the picture there is Telegraph Road in Michigan. It's a good long road, probably 20 miles long, just packed with these median U-turns and kind of the precursor to the Arcut intersection. So Jared and Mike and Brad and I guess Paul Sanders all went up to Detroit and drove the project, looked at it, and did kind of a scanning tour to see how it operated. So why do we want to use Arcuts? Why are Arcuts the thing to use here? Well, it's the conflict points. It's all about the conflict points. A conventional intersection with a divided median like this has 42 conflict points. 24 of those are crossing conflicts. You go to a J-turn, what we used to call a J-turn, now we call them Arcuts. There's 24 conflict points, but there's only 4 crossing conflict points. And that's where your real crash severity comes in, is at those crossing points. The merges and diverges are about the same between the standard intersection or conventional intersection and the Arcut, but those crossing numbers go from 24 crossing points down to 4. So Mike gave me this slide. And so let's think of it as a pond, and you throw a rock in. If it hits just in one place, if you just have one conflict point, you know what to deal with there at that one conflict point. But when you have all these conflict points and you got little, and you throw a lot of rocks in, all of them kind of mesh over each other, and it's really hard to tell what you're fixing and what you're not fixing. So after that scoping meeting, the light bulb went off in the head that this 31W project would be a great project to do an Arcut corridor in. Jared really wanted to see a corridor of Arcuts on it, in some district in Kentucky, in some place in Kentucky to be the first one. So I went to Mike and I said, Mike, is it okay if I talk to the district and say 31W looks like a good candidate? And he said, sure, if they're interested, that's a great idea. We need to find some place where we can implement an Arcut corridor. So we met with Brad in District 4, came up with 8 candidate intersections. All of them were signalized intersections. And then after looking at them for a little while, we narrowed it down to 5. And there's 5,400 and something intersections in District 4 total. And of those 5,400, KTC ranks them all in terms of the excess expected crashes there. And all of these 5 that we narrowed it down to were in the top 10% of the worst intersections in District 4. In fact, 4 of them were in the top 2%. So we did a comparison. I'm sure you can't read this from the back, but did comparisons of mainline travel time and how much time was saved. And generally, it wasn't more than about 15 seconds per intersection. The average person saved about 15 seconds with the Arcuts in there. And we also looked at the adverse travel time for people coming off the side roads. So if they had to turn right, go up, U-turn, and come back, how much additional time that took in a traffic simulation for them to do that. And then we multiplied those through by the amount of traffic going straight through on 31W versus what the side road traffic was, and came up with a total intersection time saving for each of those initial 8 intersections. And we looked at crash data, looked at the individual crashes. The district went through and mapped those crashes out by type using the crash reports, gave those to us, and we looked at where there were opportunities to eliminate crashes. So we looked at how many crashes could potentially be dropped at each intersection. And we also looked at the KTC database and the ranking for each intersection. Now, at this point, we eliminated 2 intersections. We eliminated the Pine Valley Hutcherson because it had quite a bit of adverse travel time from the side roads. And we thought there might be some political opposition to that. Plus, it didn't have a huge number of crashes. It had 11 crashes, and we could maybe eliminate 10 of those. And then we also eliminated Fairmont Centennial, which was a project that was 2 offset intersections that were all signalized, and the district was doing an in-house project to bring them together. Since been built, and they didn't want to change it again right after reconstructing it. So about that same time, the Deckard School Road intersection with Patriot Parkway, that was constructed. It was the first Arcut in Kentucky. It was designed in-house by District 4. They had multiple fatalities out there. They needed to do something. And I guess Patriot Parkway had been open about a year with multiple fatalities. And so they went ahead and put in Kentucky's first Arcut intersection there. And then after that, Brad decided he wanted to expand the project a little bit more, and he started looking south of the 31W bypass. And he looked at both Bankview Drive and Lehman Lane, which were intersections that were unsignalized, but he was being asked to make them signalized intersections. And he said, let's just do a preemptive strike, hit those two intersections and go ahead and get those out of the way while we're doing the rest of these. So you can see the simulations in the bottom. Those are cars. That's the left into the side road, but you can't turn left out of the side road. That's Lindeman Lane right there in particular near the hospital. As you go up a little bit farther, it'll scan forward here. You can see that there are some cars that will back up in the U-turn. So you can see that it backs up a little bit, but just beyond there is another traffic signal at the flea market. And that traffic signal creates gaps so that those cars can get out of that U-turn. So everything worked pretty well there. Those two intersections were also in the top 1% of the worst intersections in District 4. So we had some local officials meetings, met with Elizabethtown MPO. That was not really a big issue. Then we met with the city of Ratcliffe, and there was some concern in the city of Ratcliffe. They were not real excited about the idea. In fact, we showed them all the information on crashes. One of the folks from the city of Ratcliffe stood up and said, everybody knows that the way to make an intersection safer is to put a signal there. Why would you take a signal out? And boy, that got Mike Vaughn going. He really got fired up. And he said, now, wait a minute. Look at this graphic that we got here. There's 94 crashes over the last 5 years, 19 injuries and 2 fatalities here at 434. You're telling me that the signal's safer. And look at the graphics on all the places where the crashes are clustered is where there's a traffic signal. So that helped to turn the tide a little bit. It also helped that one of the representatives from Ratcliffe had a personal experience with an angle crash, a severe injury angle crash on 31W. So when we compared safety and capacity, really, this project's more about safety than it is about capacity. It's more about reducing those crashes. I said, the most you saved on an intersection by taking a signal out, like maybe 15 seconds of travel time. With 923 crashes over the first 3.33 miles, which is really from St. John Road up to Kentucky 447, there were 153 injuries over 5 years in those 923 crashes. So we looked at how you could reduce those crashes, and Mike and I, we didn't do an IHSDM. It wasn't an in-depth computer type analysis of crash reduction. It was really just kind of a CMFs, crash modification factors, and engineering judgment as to, by implementing these R-cuts, how many crashes we would reduce of each type. And so we estimated that, came out with about 25% reduction in all crashes, and we hope to get a 42% reduction in injury crashes out there. Again, capacity improvement was secondary. We did eliminate 5 traffic signals out of, once we'd expanded the project down to St. John Road, there was maybe 24 signals in that section. We eliminated 5 of them, but we also eliminated 2 future signals. So there's 7 places that would have been signalized that were eliminated. I mentioned the funding sources earlier. There were four different funding sources that came together to pay for this project. This is about, I guess, the 2018 6-year plan came out. There were 2 pavement rehab sections you see in the blue and the red down there in the bottom graphic. Those projects were going to be happening at about the same time we were implementing R-cuts. So Brad said, let's get all these things and put them together, not have the contractor out there twice, or 2 different contractors out there. So we also had HSIP demonstration funding. And then we had the access management project that there was still some leftover money in there, that the project that had languished. That was BRAC money from Fort Knox closure, or not closure, but from BRAC money that went for Fort Knox. And then also the city of Elizabethtown, they wanted to relocate Starlight Drive. There were 2 intersections very close together that kind of operated in one signal, and they wanted to put it all into one intersection. And so that was something paid for with local money. Some of the advantages of combining those together is it limits the delays to the public during construction. It was more practical to combine them. And then cost-wise, you get a better quality product, the rideability is much better, and it's definitely much easier to sell to local officials. So after that point, as the project continued to evolve, Brad said, while we're putting in these different R-cuts, while we've got these 7 R-cuts, let's go ahead and close up the rest of the median for that first 3.33 miles, because there's not a grass median out there. It's just a paved median that cars are turning across. The R-cut would have taken care of some of those, but it didn't take care of all of them. So we went back and looked at it some more. added 3 of what Mike calls wannabe R-cuts, where you could turn left in the side road, but there was no loon or U-turn for those side roads particularly. They just went to the next place that there was a U-turn. And we also closed the median at 7 approaches that just didn't have any left in or left out access. They would end up using the other U-turns on the corridor. So of those 10 intersections that we impacted, 6 of those were also in the top 10 in District 4. So if you're keeping score at home, that's 6 there, and the 5 earlier. So you got 11 of the worst intersections in District 4 from a crash standpoint that were dealt with on this project. A lot of them in the top 2%. So this graphic's a little bit hard to see. It's probably easier for the folks at home watching. But we closed up the median for the rest of the way. We took some things like Knowles Road right here, where cars were turning left into Knowles Road through the left turn lanes. And we closed up the median all the way through there. We put some R-cuts at strategic business locations and also at other side roads. And then there's another example of where we did it up toward Veterans Way. And then beyond that point, oops, sorry, hit the wrong button. Beyond that point, then you start to get into grass median. So we didn't close the median beyond there because there was already some grass median out there to close it. So at this point, I'm going to turn it over to Mike. And take you on.
So if you all haven't figured out by now, we love to have fun in HSIP, giving stuff funny nicknames. But if you're not having fun at work, what's the point, right? Let's talk a little bit about some of the design features for this corridor, but just R-cuts in general. There's 3 lanes of through traffic in each direction for a lot of the corridor. And so where we had that amount of width, we didn't need an actual loom. There's enough of a diameter for those U-turns that we just didn't need the bulb out or the loom. It's pretty standard practice that all R-cuts have offset left turn lanes at the main intersection. You don't have to design it that way, but generally you do get some sort of offset. But you know, we did make sure all of our main left turns off the main line had an offset left. We also incorporated some offset lefts at some of the U-turns. We had a few spots where the U-turn spots were essentially back to back or adjacent. And so in those spots, we actually, at kind of the tail end of the U-turn, shifted to make the U-turns offset lefts as well. And all that came down to sight distance. If any of you were in the presentation earlier this morning, there was a question about U-turn sight distance at one of the R-cuts. District 1 we talked about, but I mentioned that probably one of the most critical aspects of an R-cut is the sight distance at the U-turns. And so we definitely checked all of that as we went along, since we knew that that's a slow moving movement. We want to make sure people have plenty of time to execute that turn. And to get that time, they need to be able to see further and, you know, be able to choose longer gaps. A lot of our U-turns, we tried to strategically place them at existing crossovers. We're trying to be cost efficient with this project. That did mean that some of our entrances and U-turn spots were then going to be combined. So as you can kind of see in the picture, we used some dotted lane line extensions to try to indicate which portion of this crossover is more geared toward the U-turners and which portion was more for people wanting to access the business on the side there. We also, again, HSIP is very concerned about being cost efficient. We use the existing drainage facilities as often as possible, so we tie to a lot of the existing drainage. And we try to keep our right-of-way impacts to a minimum. Luckily, this corridor had pretty decent existing right-of-way, so for the most part, we were able to stay all within existing right-of-way and only needed a few minor acquisitions and easements and whatnot. We also tried to design around utilities as often as we could to minimize those impacts. We had a few, it's a big project, but we kept to a minimum. As David mentioned, this project, it just kept evolving. You know, we had all these different funding sources and different goals with all these different projects. And it seems like we were changing our mind every other week about how we were going to what we're going to do and how we're going to proceed forward. But in the end, we ultimately decided that the 3 R cuts up near and in Radcliffe, that we'd let those separately. So we went to letting in September of 19. Work got underway in late February of 2020, and those 3 were opened up around August of 2020. Here's a little bit of, next few slides will be a little bit of a look at some of our before-after performance of some of our cuts in Kentucky. This is the first one, Patriot Parkway at Deckard School Road. In the before period, we had seen 10 crashes, with 5 of those being injury, 1 fatal. You'll notice in the kind of the pic to the left, you got those place markers that have, they're colored yellow and have the star. Those were a lot of angle crashes. People trying to pull out of the side street or getting struck by main line. Since the R cut, we've not seen a lot fewer number of crashes, but those severe crashes have went down drastically. The crashes that we have seen typically are those inadvertent type, where car number 2 thinks car number 1 went, but they didn't, and they just roll into the bumper. So they've been pretty inconsequential. There's another R cut here. This is our second one we built down in US 25E. We had a number of crashes over the years with it, a lot of those being injury. And at this R cut, had seen really good reductions across the board, both in total crashes and injury crashes. Coming back up to our 31W corridor, here's one of the 3 near Radcliffe. We've only got about a year of after, so this is very preliminary numbers, and we've taken the 5-year before period and averaged it out in a per year number of crashes, so it's a little easier to compare. So on this one, not necessarily a lot of crash reduction, but so far we've had no injury or fatal, so we're on target to have a really successful reduction of those crash types, which is good. Fingers crossed we stay at 0. That's the goal. Or 34, very similar, a little bit better crash reduction, total crashes, but again, no fatal or injury crashes in this first year. So another preliminary projection of going to have a very successful after period. And then the third of those near Radcliffe R cuts here, Blackjack, we've seen a tremendous crash reduction from almost 12 per year all the way down to 2. We unfortunately did have 1 fatality at this one in the right after it was open. A cyclist was looking to make a left-hand maneuver off the 31W onto the side street. It was nighttime. They didn't have any reflective gear on. And there was a driver coming behind them. They weren't at the left turn lane quite yet, but they were approaching. And there was some oncoming traffic. And as that traffic went by, the left turner vehicle was about the time they were getting up to the end of the left turn lane. Well, the cyclist didn't take the gap. They just didn't feel comfortable taking the gap. The motorist didn't see them. They knew they could take the gap, so they went and unfortunately ran over the cyclist and killed them. Describe that particular crash because that could have happened almost no matter what intersection design we had. I mean, the only way is if you completely eliminated that left-hand turn, but it's just very unfortunate. Hopefully that's the only severe crash that we see in the after period. But again, we think all 3 of these on 31W are showing extremely good after performance. And so fingers crossed we keep that up. We've had really good success across the state with our cut so far. So our expectation is that that will stay and we'll continue to have that success. So Brad's going to finish up here, talk about the pavement rehabilitation part is a big part of this project.
So David mentioned the pavement rehab project earlier. That came together in the 2018 highway plan, and it really let us do a whole lot more with the corridor than we originally planned. We originally had those 7 individual intersections for our cuts. The pavement rehab really let us turn it into a full 3 miles through the most heavily congested portion of the corridor, close up those medians, add a lot of median U-turns. the name of the arc cuts, the wannabe arc cuts.
Yeah.
Added those in there and really turned the corridor into something a lot more than it could have been. The pavement conditions were pretty bad out here. Had been a need for a while. The underlying, will be some here in a minute, but the underlying asphalt or underlying concrete had caused a lot of issues. And then over the years, it just been patched and worked together, widened here and there, and widened in the middle, unwidened in the middle, all kinds of things. So there was some major need there, and that was the biggest complaint we had from the public and the local officials, was the rideability of the pavement through this section. So one of the first things we did, and actually this is when Andre's group still had the Pavement Rehab project. They had KTC go out and do some ground penetrating radar, drove all the lanes, got us that data back. This is one of those graphs they sent back. The red line you see there is the bottom of the asphalt layer, and the blue line is the bottom of the concrete layer. And this is all in one lane up through the 3 mile corridor. So you can see it jumps all over the place. There's some consistency, but a lot of inconsistency as well. Anywhere from 4 to 9 inches of asphalt over top of that old concrete. On top of that, we went back through the archive plans, tried to figure out what had happened over the years with all this corridor. This is intersection of Ring Road and 31W. So looking through the archive plans, the 2 southbound lanes were constructed originally in around World War II in concrete. About 18 years later, in 1959, the 2 northbound lanes were constructed with originally a depressed median, also constructed in concrete, but at the same time, they overlaid the original 2 lanes with asphalt. So that's where some of that variance in asphalt depth came. And then in the years following that, as E-Town expanded and moved to the north, and then this area commercialized, the median was slowly filled in with various crossovers, turn lanes, various different projects that flushed the median out. And then also a few projects that added a 3rd lane in select sections where the traffic volumes are the highest, as well as right turn lanes and different things. So, and all those median and outside additions were all done in full depth asphalt. So you had a lot of combination of existing concrete overlaid with asphalt, and then full depth asphalt next to that, some median crossovers that were concrete and or asphalt that were overlaid. So it was a mess out there to figure out what to exactly do with the pavement rehab project. We looked at a lot of different options with the rehab. Gary Sharp at Palmer ran into a lot of PaveME analysis. We worked with central office pavements. We considered a lot of different things. We looked at completely tearing up all the concrete that was there. That would have been the best case for the pavement and in the long run, but it was simply cost prohibitive, and maintenance of traffic would have been a nightmare. Ultimately, what we ended up moving forward with, we milled either down to the top of the concrete 4 to 5 inches, whatever we hit first, and put back a fiber reinforced 7622 binder asphalt. So a very, very stiff pavement in an effort to try to prevent some of that reflective cracking back up through that original concrete and all the different underlying medians there up to the surface. So in addition to that, those underlying concrete lanes have caused us a lot of issues over the years. In varying weather conditions, they would want to expand and contract at different rates, of course, and it caused shove ups and humps here and there, and then they'd recede back in the winter. We paired a lot of those over the years. Some of those we just passed the surface. We decided to try to make a longer term fix there. We implemented both what we call wide relief joints and narrow relief joints. The wide relief joints every couple thousand feet. There were about 8-foot cutouts filled back with asphalt material. And then the narrow relief joints were just a 4-inch relief every couple hundred feet, in an effort to try to give that concrete some room to move without affecting the asphalt above it. The next big thing we had to tackle was the construction phasing and MOT. This particular route is the most heavily traveled road in District 4, other than I-65. Depending on which section you're in, you're upwards of 35,000, 40,000 cars a day. And then for us, that's a very heavy road. So we had quite a few internal meetings. Obviously, we had meetings with the local officials on how this would all work. The funding availability, again, we had a timeline on the pavement rehab funds being in the highway plan. We had to get those out the door at the same time as doing some of the safety work. Our main goal was to limit disruption to the public as much as possible. There weren't really a lot of alternate routes, and this is really the primary commercial corridor in Elizabethtown there. We ultimately decided to split it into 3 segments, basically a north, center, and south segment. In particular, note the north segment had the mall, Walmart, a lot of those commercial areas that are heavily traveled in the holiday shopping season. Some other concerns we had were maintaining business accesses. A lot of businesses had two accesses or on a frontage road or a backage road, but there were a handful that only had a single access. So we had to specifically phase around them to make sure they maintained access throughout construction. We did limit left turns in certain phases. We took two turn lanes down to one or one down to none in certain areas. And then we had concerns about all the signals to this stretch are in a system together. And we had concerns about that system not functioning if we removed all those loops. So prior to construction, we set up to have radar sensors installed at all the signals to replace the loops. And then those radar signals through the various phases in construction could be re-aimed to wherever those turn lanes or through lanes were to try to maintain as much signal capacity and system as possible. Another big thing we didn't want to leave it torn up through the winter, not only for snow and ice reasons, but again, back to that commercial corridor and just holiday shopping season. We wanted to maintain during daylight hours, two lanes in each direction at all times. At nighttime, we did allow them to drop down to a single lane at night for paving operations. And then we originally looked at A+B bidding to try to incentivize getting done sooner than later. Ultimately, with some budget concerns, the onset of COVID and just scheduling, we decided against that, but we did set up fixed completion dates for the individual 3 sections. So our intent was to have only one of the 3 sections under construction at any given time and not have the whole 3-mile corridor torn up. So public involvement side of things, again, we had a lot of back and forth with local officials, both largely Elizabethtown, but Hardin County and Radcliffe as well. Obviously, they had a lot of concerns about what this would look like during construction, but they also saw the need, especially in the pavement rehab side of things, with all the complaints that they had out there. We had quite a few meetings with the large businesses and the larger property owners in the area, just to work out some specific concerns, let them know what was going on. We never necessarily had a public meeting per se, but we had all the information out there. We did ultimately create a website, us31w.org, that is still active. Right now, we're using that to disseminate construction updates to the public, but on there as well are plans of what the ultimate corridor will look like, the schedule that gets updated as the construction moves forward, and then some information on our cuts, what benefit those provide, and safety benefit of all that. So this is one of the displays that's available on there that shows the ultimate corridor and where the medians will be. The current construction status, originally our plan was to get segment 1 and segment 2, so the 2 northern sections completed this calendar year. However, we ran into some change orders with some unknown underlying conditions, as well as the contractors had some staffing issues this year, which is pretty common across the state right now. So right now, it looks like we're going to get only segment 1, the most northern segment, wrapped up in the next few weeks here with that 7622 asphalt binder, especially with the asphalt fibers. Our paving season ends middle of October. So we're only a few weeks out and we're done for the season. So segments 2 and 3, the southern pieces will now be done hopefully in 2022. This is the current condition just a couple weeks ago. Palmer's went out and took some drone video. You can see they're working on the center of the roadway. They actually started in the center. They moved to the outsides, one side and the other, and then they're going to back to the center to finish up the drainage boxes, finish up the concrete median, and then once that's done, they'll put asphalt surface on everything, put down the final striping, and then we can move to the next section to the south. That's all we got. Any questions for me or anybody else? Anything to add?
How can they handle a lot of the trucks?
The R cuts? Yeah. It depends on how we design them. A lot of these, we saw some graphics earlier, have the looms installed. Those looms, depending on the location, basically we designed as big as we could fit in the right of way. Some of them are up to 60 WB67, some of them are only WB53s, 50s. But at this point, we had a couple of complaints of larger vehicles, particularly farm type vehicles that couldn't make those turns. But in general, they seem to accomplish it just fine. Now, I mentioned there's some 3-lane, or I think David mentioned there's some 3-lane sections through here existing. In those existing 3-lane sections, 6-lane, 3-lane on one side, we chose not to put a loom in because it's 3 lanes with, in addition to an outside shoulder. So we have a lot of pavement width there. From what we saw in Michigan in those similar situations, Paul and I witnessed a few trucks make U-turns with no issue in those in a very similar situation. Plus, where those 6 lanes, there's very little right of way to work with as well. So we're hemmed in on that side as well. So
With those loomless situations, do you have any issues with the additional conflicts, especially with truck movements?
to be honest, we don't know yet. So the limbless areas aren't constructed yet. So I don't believe so. Again, David alluded to this earlier. We still have signals spread throughout the corridor. So even if they have to wait for a signal to turn red, to create a gap, I don't think that should be an issue. But we haven't seen it on the ground yet because it's not open to traffic. So.
What's your typical drainage treatments in there, like, because I'm assuming they're curved sections?
That's correct. So the middle is all raised island. There was a lot of existing drainage network under 31W. For the most part, we utilized it where we could. We tied back into it and used the existing outlets. I think we had to add a few here and there, but in general, we utilize the existing drainage system that had been added since the 40s, piece by piece.
Just using standard curb boxes on those curves, I guess. Or,
Yes.
yeah.
We didn't have to take any drainage off the project and, buy right away to take it down to the stream somewhere. Everything worked with the existing drainage that was out there.
Any other questions?
Those expansion joints in that concrete, those are since them over 4 inches wide. How did y'all excavate out the concrete that way, y'all?
I haven't been out in the field. I'm assuming they've used just a saw blade. Paul, is that correct? For the narrow expansion joints, the 4-inch expansion joints. We assumed that they would use either a saw blade and do both, or they've got like 4-inch wide trenchers. But to be honest, I haven't been out in the field to see how they've accomplished those. And we backfilled those with just a flowable asphalt material, to provide some flexibility and movement there. So. Gary, do you remember exactly? Mr. Sharp designed those for us.
We vary really depending on the stresses. 8-foot separation, 8-foot joints. It varied by the number of what we found in the stresses.
Yeah. We had some existing, I'll call them blow up areas that we specifically addressed with full dig outs and full replacement, remove that concrete and everything. So we had several of those, and then interspace between those, we had those 8-foot wide relief joints to try to relieve additional stresses, keep that from happening in the future.
We try to keep those did already have the stresses that led us that way. About 800 feet is what we tried to get. That's how we shot what we shot for.
Yeah, about 800 feet roughly is what we shot for with the wide. I believe I said a couple thousand feet earlier. That was incorrect. So. Any last questions? I think we're about out of time.
All right, let's give our presenters a hand.